This is the twin paradox quiz in which you are going to explore the twin paradox in more detail than we have so far. So we have Remus, who decides to take a journey on the intergalactic conveyor belt, leaving his twin Romulus on Earth while he is gone. Remus jumps aboard the intergalactic conveyor belt on his 21st birthday and travels away from Earth for 5 years as measured on his watch. At the end of the 5 years, Remus jumps off of the conveyor belt on which he was traveling away from Earth and onto a second conveyor belt running parallel to the first but in the opposite direction. Both conveyor belts have a speed of 0.8 c. Remus rides on the conveyor belt until he returns to Earth, where he is reunited with Romulus. So, for most of these questions, you should be using either time dilation, possibly length contraction, or Lorentz transformation equations, or just physics 161, where you have velocity is equal to distance over time. So I'm going to skip ahead to part F, in which we are told to consider 3 different reference frames: the Earth reference frame, the first conveyor belt reference frame, and the second conveyor belt reference frame. Let the event of Remus's departure from Earth occur at the origin in all 3 reference frames. In each reference frame, the event occurs at position 0 and time 0. Starting with the coordinates in the Earth frame for the event of Remus's jump, use a Lorentz transformation to find the time coordinate of this event in the second conveyor belt frame. The whole purpose of using these conveyor belts is because that, as we saw before with the twin paradox, one of these twins is not in an inertial reference frame for the whole trip. So the twin that goes away and then turns around and comes back has accelerated. So now, instead of using a non-inertial reference frame, we're going to use 3 different reference frames. Each one of these reference frames is now an inertial reference frame, and the twin that turns around and comes back is just switching from one reference frame to another reference frame. So for F, it may be helpful for you to look at the 3 different reference frames. So you have the Earth, and then you have a conveyor belt going this way at 0.8 c, and then you have a conveyor belt going this way at 0.8 c. Now, we're going to say, let the event of Remus's departure, let's call this event 1, that occurs at the origin in all 3 reference frames. So what we're going to do is draw a big red X here and here on each conveyor belt. At the moment that Remus makes his jump, these X's are lined up with Earth. Now, sometime later, Earth is still here, and you have the conveyor belt which is going this way. So now the red X will be somewhere over here, and then you have the conveyor belt going the other way. I should probably make this one longer too. And the red X will be at the same distance away, but in the opposite direction in Earth's reference frame. So in Earth's frame of reference, the speeds are the same, so the distance traveled by each red X should be the same, but in opposite directions. Okay, so I'm going to leave you here for now, but you can always ask me if you have any questions as you are going through the quiz.